recording on this computer and double checking that I'm bound. My icon is bouncing, and yeah. Okay, this is the regularly scheduled meeting of ITSE 2347 for November 6th, 2019. And counting tonight, we have 4 class meetings. So we have tonight, this is the 6th, then we have 1 meeting on the, after this one on the 13th, and then 6th, the 13th, we meet on the 20th. We do not meet on the 27th. That is the day before Thanksgiving. And you want to thank them for that, because that is a real nightmare to be out on the road. In fact, I don't even try to do it anymore in the day of Zoom. I just say, okay, we're not gonna meet in the physical classroom, but they've given us that off. Then we have another one on the 4th. And the option to go 1 week after that. Okay, so today I'm going to talk about some stuff, and I'm not going to go for a long time tonight. So everybody is going, praise the Lord. So I'm going to talk about some things of transaction locking. Transaction locking is what allows more than one person to access the same data at the same time. And if you look at it, why is Access is considered to be not a very powerful database? And the reason why is because Access is considered to be a single user database. Now, this isn't exactly true. Access can have multiple users. However, only one user can be updating one table at one time. So when Access locks, when somebody reads a table, that table, nobody else can be reading that table. Now, this is fine until you get 5 or 6 people busily working on the database, and then they start colliding with each other and having to wait for long periods of time while something runs. In modern databases, in things like SQL Server, we have, see if I can pull this up. We have the concurrency idea, and this is the URL. I'll post this URL for you. And so this is the concurrency post. This is a blog, and concurrency. Oh, thank you. I'm being told that I haven't turned on my monitors here. We'll give that a second to wake up here. But concurrency can be defined as the ability of multiple people, multiple users, to access shared data at the same time. Now, obviously, 2 people cannot access the same data at exactly the same time. Are those things going to wake up? Yes, I see them. So we have to have a way of resolving the conflicts, and we do this, okay, to the extent that multiple users can interact with each other without running into each other and interfering with each other. But as soon as 2 or more people start working on the same data, you're going to have some conflict. So that's what the problem is. The databases, though, as you get up to the more powerful databases, the way they handle this is gets really very, very complicated. And Oracle, for example, can have thousands and thousands of people all accessing the same data at the same time. SQL Server, less so. SQL Server, in theory, can, but it doesn't always able to do it. So there's 2 approaches to it. We have 2 down here to talk about 2 approaches. We have the optimistic concurrency model and the pessimistic concurrency model. Optimistic says, oh, everything is going to be fine. Pessimistic says, everything sucks. Make sure that nobody gets, no two people can access at the same time. Optimistic says, well, you know, we have so many resources that probably no two people are going to go grab for the same one at the same time. For example, we only have so much space in our bathrooms. Here we have a bathroom, and we have space for, but what if everybody decided to go to the bathroom at the same time? Well, it's going to be a big traffic jam. What if everybody wanted to get a drink of water from the fountain at the same time? So the pessimistic model says, I'm only going to allow, you have to take a ticket to go get a drink of water. And then you have to, you know, present your ticket, and then we let you get a drink of water. And then the next person gets to come in and drink of water. Versus the optimistic that says, hey, probably it's just going to be sitting there empty most of the time. So whenever you want a drink of water, you just go get a drink of water. Optimistic versus pessimistic. Pessimistic says, we have to control you. Okay. The optimistic is considered better. Pessimistic is the way that SQL Server typically runs. The concurrency model, the pessimistic, which is what the SQL Server uses, says default behavior says, I acquire locks to block access to data that another process is using. Let me talk a little bit about a transaction. Now, we've seen a transaction happen. So you have a transaction in there, and the transaction begins. Where does our transaction begin in SQL Server? When we say execute, we begin a transaction. We are in what we call an implicit transaction. Transaction begins, it goes through to completion. When it gets to the end, it exits and does what we call commits. Well, what happens if there is a problem in the middle of it? What's that? You get an error. And what happens? Does it complete or does it quit? Well, sometimes it quits and sometimes it completes. And I want to talk a little bit about that today. But the transaction has a beginning. So it has a timestamp, a begin transaction, and it has an end transaction. The default for SQL Server is when it starts, that's the beginning of the transaction. When it ends, that's the end. But I can do that. I can come up with another way. I can do that explicitly. I can say, okay, here is the beginning of the transaction. Here is the end of the transaction. And at the beginning of the transaction, I say begin transaction. At the end, I say commit. Now, in SQL Server, let me find my file, query one. Okay. We have a couple of ideas. Set implicit transactions on. By default, set implicit transactions off. This is the default. Implicit transactions are off. In other words, auto commit. The transaction begins, the transaction ends, it commits, it writes it to the database. Versus auto commit off, which is implicit transactions on, where we have a begin. I have to say, okay, here's the transaction beginning, here's the transaction end. Now, when we were working about that communication between two web pages, two different processes, we saw some of that begin the transaction and commit. A transaction is a set of things that have to happen all together. They have to happen and nothing can get in the way of it. They all have to happen or they all have to fail. Think of a transaction like getting on an airplane. Getting on an airplane, you want the airplane to take off, you want it to fly to its destination, and you want it to land. If something is going to go wrong, you either want it to go wrong and leave you at your beginning, or at the end, you don't want it to leave you someplace in the middle. Okay, so you either don't start it or you finish it. And we have a way of saying, okay, we're going to go, if we can't finish it, we're going to go back to our starting point. This would be like I'm moving money from my checking account. The simplest idea, I move money from my checking account to my savings account. Begin transaction. I have to take money from, I said, checking to savings. Take money, read my savings account. Take money, take $10 out of it. Read my savings, read my, which the other one, put $10 in there. I want that to happen. All of that has to happen, or none of that can happen. So that is the idea of the transaction. I can't make it all happen at exactly the same time. And I have to be very careful that it all does happen. Go ahead.
So at my job, I have that problem. So maybe I run this script. I run the script like insert or update. And
Insert.
then I found out, oh my God, I should not do it because I'm working with the real data. It's gonna affect in the real data. So if I set that one on, it gives me the option that I can like commit, that auto commit. It doesn't work.
Mhm. Well, I am working with that to try to figure out exactly and come up with some real world examples of this. I've been working, I don't know SQL Server here as well as I should, but I'm working on it to come up with some examples. Um, there's several problems that you run into when you are making multiple inserts. So if all you're doing is inserting one row into one table, you're in pretty good shape. So I'm inserting data. I need to put a row into a table. Somebody says, okay, let's create a player. Okay, I put the player's name and the player's, if I have a password, whatever, the player's um, into the web page. The web page says, okay, go, insert it. It happens. Everything's fine. Several things have to happen there, though. The procedure checks to see, is there a player by that name already there? So the procedure is going to check, is player Joe already in the table? No, he isn't. Therefore, now the insert proceeds. What would happen if somebody between those two things inserted Joe? Okay. So now I'm going to have a failure. I'm going to throw an error that's going to get logged. In other words, I'm going to fail to catch that in my procedure because I didn't set the transaction. And I'm going to try to add transactions into this idea. So the idea would be, I would say at the beginning of the procedure, begin transaction. I want to check and see if the player is there. If the player is not there, I'm going to insert the player and then commit the transaction. Pessimistic assumes that, I'm going to take the pessimistic approach and I'm going to say probably somebody is going to collide with my operation here. Probably I'm going to check to see if player Joe is in the database, and I will, someone else is going to come in there and insert Joe before I can. So the pessimistic says, I'm going to lock everything I'm going to touch. So I want to lock all of the records. Now, what do I have to lock? I have to make sure that nobody can insert Joe. Okay, so I have to pretty much lock that table. I can't let anybody insert into that table while my process is running. So I want my process to run pretty quickly. Optimistic says that I'm going to go ahead and try to insert it, and if I fail, I try to fail gracefully. So the transaction is the basic unit of work. A transaction commands that read and update the database, and nothing is supposed to get in between them and cause them um, um, to fail, one part of it to fail. A transaction has a begin. So we have a begin tran. You can also say begin transaction. And the end is marked by either a commit transaction or a rollback. Rollback says, go back to the start. It didn't happen. Commit says, make it happen. This comes from early database. Somebody came up with the idea that databases have to pass the ACID test. Now, it sounds to me kind of corny, but anyway, a transaction has atomicity, and that's pretty nice. Each transaction is treated as all or nothing. So a transaction has to be, all of it has to happen or none of it happens. Consistency ensures that a transaction won't ever give you a wrong data read, and we're going to show you how that can happen. Isolation, consistency. I always thought they put the C in there, consistency, so it would spell acid. I mean, who would want anything to do with the database? It wasn't consistent, but they wanted to spell acid. They didn't want to spell aid, so they put the C in there. Isolation, one process doesn't affect the other. And finally, durability. Once it's committed, it stays that way. It's not always written to disk, by the way. Sometimes they go to a holding area that first, and then they're written in blocks. Okay, here's the things that can go wrong. Other behaviors, these are problems, consistency problems. We can lose updates. We have a lost update when two processes read the same data, both manipulate the data, changing its value. So this would be like if I were moving $10 from my checking account to my savings account, and my wife were also accessing the same account at the same time. And it gets interleaved, and both of us end up debiting the account, and we lose one of the records of one of the accounts. That's fine if we do it for debiting, but when we have a lost update, when we're adding it back into the other account, that's where it gets bad. Did you have a question, Juana?
Those are two different transactions, and they take time for the time. Remember, they create something with the time, so one is individual like another.
Right. They would be, you're talking about my wife and I accessing that would be two individual transactions. But if they were not two individual transactions, if they were not independent, we would be vulnerable to the lost update. That is one thing that happens. Another one is called the dirty read. And we'll see that there are different ways that we have of protecting ourselves from this. So a dirty read, when I have changed a record, but I haven't said I'm finished yet. So I've changed something in the database. I have added this player to the database, so or updated it somehow, but I haven't committed that transaction yet. And it's possible for it to come along and read that, and then it rolls back. That's called a dirty read.
Yeah, that can happen if you are trying to do a transaction with different tables.
Yes, it can very easily.
Mm-hmm.
Yes.
You update the one, and you are with the second one, and somebody wants to use the first one.
You run into that with, or at least you used to run into it with, on the web. You would be trying to book a flight or something. So you read, and oh, there's my flight. I want that flight. And you say, okay, give me that flight. And it says, fine, there you are. And then you say, okay, thank you. And you say, okay, commit, make it happen. And it says, sorry, that flight isn't available. That was a dirty read. Okay, so you read something that somebody had already bought.
Yeah.
Okay, used to be they would sell two people the same ticket. to the same seat, and they would have two people. It would be possible for two people to appear at the airport with tickets to the same seat. That's not possible anymore. We've gotten around that. But 20 years ago, you could do that easily. And they just found it to be cheaper to buy somebody a free ticket than it was to fix it. The other one is non-repeatable read. A read is non-repeatable if we issue the same read twice and we get two different answers where something comes in between them and does it. Again, we have a transaction problem. And finally, the phantom read, two select operations. It's essentially, it's a repeatable read problem. We get a different reading on two separate transactions. And this brings us to the thing of isolation levels, to the idea of isolation levels in it. Transactions run at isolation levels. First of all, let me talk about this one a little bit. I have a table here, if object ID so I create this table. I call the table test batch. I put some, there's the table. I put some data into the table, and then I fat finger it and I misspell a word. I have a syntax error. Now what happens here is that the system tries to, what? What's going to happen?
I think it may, if it goes through without the syntaxes, it could fill up the two first records.
This particular one, if you run it like that, it will always abort everything because the system never is able to generate the code that will execute this. Since we have an implicit transaction here, since it cannot possibly do all of them, it won't do any of them. Okay, so it will give you a syntax error. It will not put anything in. It will create the table, but that's why I always say have a go after you create the table. At the close, the one at the end isn't as important. Okay, so this one has a syntax error. Now let's contrast this with this one. Instead of, it's exactly the same thing. I create the same table, put the same data into the table, except this one, the primary key is column A, and notice it has a duplicate in it. Okay, this is going to be a runtime error. This one is different. This one isn't a syntax error because as the system parses this one, it's going to be fine. The system isn't going to notice that that there's a duplicate primary key until it actually tries to do it. So it's going to hit that primary key, and that last one is going to fail, but the first two are going to work. This one will return the rows 1 and 2. Okay, this one won't do anything. This one, if I try to execute this one, execute. Okay. Something is wrong here. It looks like I have managed to lock up my system with what I was doing. I was practicing with this. I was doing some, let me try something here and see if I can get it to work. Commit. I was practicing with this just before class, trying to figure, try and get some ideas. So a commit has no corresponding begin. Go. I have some locks that are not coming off here. I've got some stuff that is still running here that let's see, I need to view. Say what?
What are you getting?
I'm trying to drop the table and the system is locking up. Therefore, I have a row locked in the database that I need to unlock. Let's see, this is in the Scratch database. Programmability, service broker. I'm going to restart the database. That'll fix it. Okay. Now, I don't know whether this will. Let's try this, execute. Okay. Okay, what did I do with that? There. Okay, then we should work. If I try to execute this, executes, but it doesn't return any rows. And when I get to the end and I say select everything from test batch, it returns no rows at all, but nothing got inserted. The second one, when I execute the second one and I say to go, but the error is in the data. When I say to execute this, it also aborts, but notice that 2 rows got inserted there. So when I say to select them, I see the 2 rows that are turned in. I will have the same issue if I put in a bad table name, a typo on the table name. It will abort on the second one. It will abort here, but it will put in rows 1 and 2. And then finally, if I put in all 3 of them, it returns rows 1, 2, and 3. Now, I could get around this if I put in a go here Well, here, if I put a go on line 27, now when I execute this, it's going to hit that go and everything will happen and 2 rows will be affected. So the go breaks the batch up and says, okay, that one commits. So I have the beginning of a transaction here on line 25, transaction begins, commits on line 26, then a new transaction fails. There are the isolation levels. This is how we talk, that's what we're going to talk about right now, is in the isolation levels. And the isolation levels tell me how each transaction will run. By the way, the default isolation level is called repeatable read, meaning that if you read twice, you're always going to get the same thing. Let me go back and talk about each of these. The first one is isolation level read uncommitted. This is the most dangerous one. This one will allow almost anything to go wrong with it. So if I need to have any kind of safety in this, and maybe I'm just doing something, maybe I'm only counting books, how many pages there are in the book or something, where I don't really care. I just need a good idea. No, if I'm 1 or 2 off, if I get a couple of errors in it, I'm okay with that. And so it's going to be a long running transaction that I want to be able to run with other transactions. So if I set the and this is the command that sets it. If I set isolation level to read uncommitted, I have a transaction that isn't going to interfere with anybody else. Why? It's just going to take whatever it gets. So it will take dirty reads. Let's see, let me pull this up. Isolation level, read uncommitted. Everything can go wrong with it except for a lost update. So if you update under a read uncommitted isolation level, then that update will happen. Everything else goes wrong. Its implement can go wrong. It allows read applications. They don't take any locks. It just reads whatever's there and reports what it gets. It can get dirty reads. It can get uncommitted reads from other people. It can get phantom reads, all sorts of things. When using, but this is several things that it can do. When using this guy, SQL Server can and probably will do what we call an allocation order scan. That means it's going to just start at the beginning of the table and plow through it. It doesn't use any kind of indexes, anything like that. It just starts at the beginning, starts reading, and it just reads. So this is a good one for I'm doing a table level scan. I want to, how many pages do I have in my entire library where if I'm close, it's good enough. Can also happen that I have read a row before it's updated and then the update comes along and moves it. So things can move around in here while I'm in the process of reading it. So this is not something that you normally do. It's considered to be a sloppy, so uncommitted read. If you want to think of it as sloppy read. Read uncommitted. Finally, read committed. 2 varieties it says here. It ensures that the server never reads data that another one hasn't committed. So this one, when you're in read committed isolation level and you start a transaction, it will always lock the transaction, a write transaction. If somebody is writing a record, it will not let anyone else come along and read that until it commits. You're just going to be sitting there while it's finishing up. So if it's a long running transaction, we're going to tie it up for a while. Think of it like we used to have one. I worked at a college once at Austin Community College, and we had a 3-story building. Yeah, 3 stories. And there were bathrooms on all 3 floors. And the classes would break at 10 o'clock. About 9:15, the janitors would decide to clean the bathrooms. And what they would do is they would go up and they would lock all three bathrooms in the building. All three of the bathrooms would be shut down. Now they could go clean them very quickly. But until they got done cleaning them, nobody could get into the bathroom. So the students would come out of class at 9:50 looking for a bathroom, and all of the bathrooms are, sorry, closed for cleaning. That went over really big. And so that was an example of a read committed. They weren't going to let you use a dirty bathroom. I mean, heavens, we can't do that. So they would lock them all. And until I got done with all of them and they took those locks off, nobody could use it. Nobody could read the bathroom, but whatever. That's an example of what happens when you have that, because sometimes there's transactions that will lock up the whole table. So if I'm changing something that is changing lots of data, chances are good that I'm going to lock everything and you're going to be sitting there. Never reads uncommitted data. The one that we typically use, the default, if you set it up, if you just take the default, you have the repeatable read isolation level. So this one, if you don't do anything, if you don't say anything, you've set isolation level to repeatable read. When you set the isolation level, you set it for all of your transactions. Okay. So this is the one that you typically have. And it's probably the better one. I mean, I guess it's the better one. It's a pessimistic isolation level. It assumes that we're going to need to do it. It ensures that if a transaction runs twice, the data cannot change. Issuing the same query twice within a transaction cannot pick up any change made by someone else. And it's got a cost. So it talks about it. Non-repeatable read is a desirable safeguard. This is considered probably the best of them. The cost of it is when I take a transaction, when I take a lock on a record, I have to hold that lock until my my transaction completes. Couple of others, there's another one called a snapshot that isn't very usable. And then the strongest one is what we call the serializable. And this is where we need perfect isolation. And let's see, it adds the repeatable read level, adds to the repeatable read, meaning that nobody can possibly get in between any of your transactions. Either they're not allowed to read, they're not allowed to write. So it's going to take an exclusive lock on every row that you're going to touch. So if you say select all the rows from a table, it's going to lock that entire table until you say commit. That one is very expensive, yes. Running under serializable. That's why that most of the time whenever we're running in just the database runs in repeatable read isolation level is the default unless you change it. So it runs with auto commit on under repeatable read isolation level unless you change it. And I wanted to get some examples of that. I just haven't been able to come up with any. Here was the one that I was working with that select from test batch with UPD lock, update lock. So I'm going to lock that record. This is how I would explicitly lock a record. So, and when I was playing with this, this is how I managed to lock up the database like that. Let me show you what I was trying to do, and I'll give you this and see if you can work on it and get it running. Okay. I create my table, insert into the table AABB. Probably should have a go right there. Set the transaction level to read uncommitted. In other words, I've set it to a very promiscuous isolation. I'm just playing around with the isolation levels here. So I'm trying to get it to do something that makes sense to me. And this is what I was doing when I managed to lock up the database where I couldn't drop the table. So begin the transaction. And I say select from test batch with UPD lock where column A is equal to 1. In other words, I'm going to select this record right here. Lock it. Okay, so basically, and let's see, set implicit transactions. I should set them off.
While you are doing the select of log where all that is equal 1, and then cells, I want to use your table. I cannot touch all that equal 1.
That's the idea. That's what I'm trying to test here. So I want to see it do something. And what I'm setting my implicit transactions off. That means that I should have to say commit before it commits. I don't want this to commit automatically. So in other words, no, it needs to be on. When implicit transactions are on, auto commit is off. Okay, so auto commit is off. Implicit transactions. I want to begin the transaction. So here's my table. I drop my table. I create the table. Now, set the isolation level to read uncommitted. In other words, I'm setting it to the most permissive level. I want it to let me do anything first, and then I'm going to gradually move it up and as I get it to doing what I want it to do. So I want it to, at some point, I want to see it block me, but not right away. And I don't want to see it lock up my tables, but I'm probably going to do that anyway. So then I begin the transaction, and I select column A is 1. And I say, okay, lock column A. So here we go, gathering nuts in May. Execute. I've locked column A. So I've selected, taken an update lock on column A. Okay, I cannot access column A because this transaction can. Here's another user. This is a different user, a different query. Okay, this guy also sets his transaction level to read uncommitted, and he tries to access column 2. Now, here's what I'm thinking should happen. It should happen. It should allow him to access column 2. When I execute this, we block. We're in locked up mode. Okay. Now, I don't know why that's happening. That's what I'm trying to explain here. So this is what I'm trying to do. Anybody got any ideas? I'd be happy to hear them. I'm going to go back to query 2, and I think I still have this locked up here. And I'm going to say commit. Now, commit should let the other one go. because this one is now committed. There's nothing that's locking it. So let's see what's going on over here. Query 3 is still locked up.
It's like they are fighting for resources.
Well, they are. But I should not be going to the same, I'm not accessing the same rows. They got two different rows. One of them,
You are accessing the table.
I'm accessing the table, but I should not be, because I have it set at a very promiscuous level. But I'm taking it, I say with an update lock. So I think that might be the problem. Maybe if I just said select, it might happen. Now I don't.
I would like to see is you lock the table with one of them, one specific row, and with another try to read it to see if you can.
But don't take the update lock. Is that what you're saying? Without the update, I'll give it a try. Let me see if I can get out of here. I've canceled the query. So if I take this update lock off, from I'm gonna row 2, and well, I'm gonna go back to 1. I'm gonna get 1 right here. Okay, so I'm gonna select where 1, begin the transaction, select 1, execute. Begin the transaction. Here I select 2, execute, and I'm blocked. And I don't understand why that's happening. And so I've been trying several things. What I want to see, okay, it's okay if it blocks because it's taking a table level lock here. But why, when I come over here and I do a commit, when I commit here, I want to see query 3 finish. I want to see it go ahead. And why is it still sitting there locked up? Something with a pointer. Don't point your finger at me. It's not nice to point. What? Try what now? Okay. How will I change it?
Because you commit once,
Mm-hmm.
and then you unlock it, and you commit again, and now maybe it goes down.
Okay, so now maybe I can start it now. From here, this is query 3, and let's see what happens if I start it. Now, notice he still locks. And the other thing that I notice is that when I try to drop the table, well, he dropped. Okay. Execute, okay, that works. Now, there's why, I'll try setting that transaction level. He still locks. And I'm going to try it the other way around. I'm going to go over here. I'll recreate the table just to make sure everything is dropped. So execute that. Now I'll go back to this query and I'll do this select, execute, and something is still is running and keeping that. And I'm not sure exactly how to see it. There is a way. I want to see my locks. Tools, options, let's try that. Anyway, the idea, what I need to find is how do I see my locks, and I guess it's time for Google here. SQL Server, view locks on a table. SQL Server, SP Who2. SP Who2? I don't know. SP Who. Let's try that and see what we get. Doesn't look like I'm gonna get anything. SPID 53, runnable. Well,
so you can see the username and the password.
I can see, yes, you can see quite a bit of stuff in here. There's quite a few things in here that we haven't really done. That's one of the things I wanted to do here. I'm still trying to work my way through this stuff. Anyway, that's kind of where I'm at. I'm trying, what I want to do is I want to set up a table. The table will have a couple of rows in it. One of my process, and then I'll have two files, two queries. They'll be running in different windows. One of them takes a lock on one of the rows. The other one comes along and tries to take a lock on the same row. It has to wait. First thing I wanted to do, I've got two rows, so I've got a table, it's got two rows, column 1, column 2. Well, excuse me, row 1, row 2. Take a lock on 1. The other one comes along, takes a lock on 2. I expected those to go together. Now, I don't know. Maybe I should change the isolation level. Maybe the problem is I have such a
Probably the problem is that you need to liberate that after some time. You cannot hold it forever.
well, I'm going to change the isolation level to repeatable read. And I'm going to see if that changes how it's behaving. Because that's whenever I'm working with it and I'm trying to get it to do something, I want to find out, what can I do to change the behavior I'm seeing. So I want to do something and have it change, and then I can kind of try to figure out what's going on here. So I'm changing the isolation level to repeatable read. Remember that this is the isolation level. This is the middle level of them, and this is where it runs by default. Okay, so I'm going to try that here. So come down to here, and I select AAA. I'm going to take this update lock off of the second one. I haven't run that second one yet. So right now I'm sitting right here. I haven't run the second one. So this one is running. I've begun the transaction, and this one's in the middle of a transaction. I've not gotten to the commit yet. This one, along, we set the transaction to repeatable read. Begin the transaction now. Here I try to select the other row. So I've been where it's 1, this one's 2, and I say execute, and again, it blocks. My question is, why is it blocking? It should not be blocking because I'm trying to select a completely different row.
It has to be something with that line.
Well, I don't doubt I have to do something with that line. But what I wanted to do was I wanted to see that one execute. So I was expecting my expectation was that when I said select 1, it would select the row 1. Then I go to the other transaction and I say select 2, it would select the row 2. Now I go back to 1 and I say select 2, that will block. And then if I commit the other one, it'll go. So what I wanted to do is block 1. So in other words, I want to be selecting where COLA is 1. I'm going to try to select them both. Okay. So this one is going to collide. So I'm going to try to select here. I'm going to do my commit. So begin the transaction. Select where it's 1. Execute. Okay, 1 AAA. Got him. So there, but I haven't committed yet. Now I come over to the other one and I'm going to try to select the same row. Execute. Now I expected that one to block. That I expected. I didn't expect it to block when I was selecting row 2. I expected that one to work. Now what I want to see happen, if I come back over here and I say commit, in other words, this transaction is finished, execute, I want to see this one finish, but he's still locked.
So maybe it's locked the whole table.
It sounds to me like it's locking the whole table. Okay. I'm going to get on some of the blog sites and I will trace this one down. Okay. I don't want to go real late tonight with it. Anybody online got any suggestions? Thing you want to see, try. But what I'm expecting to happen is that this one will select that guy. The other thing I notice is even when I turn him off like that and I cancel him, when I try to run him again, he still blocks. So something is keeping the transaction open. Try the commit. This one is working okay. This one executes and finishes. The other one does not. So the other one is somehow leaving something in. When I start this, I wonder what would happen if I shut this one down. There are uncommitted transactions. Do you wish to commit these transactions? Now that was something I was curious about. I want to explore that a little bit more. There are uncommitted transactions. What are they? I'm going to cancel. I'm going to go to this one and I'm going to say, what happens if I turn uncommitted transactions? Do I wish to commit? I'm going to go.
Very one.
I hear somebody saying something.
Oh, did you run a transaction in query 1 maybe?
I did. I have the transaction is just a begin transaction and a select. Yes, I have a transaction in query 1. Let's see. This is query 1 right here. So I have a begin transaction, and just all I did was that one select, and now I have a commit. Okay, so commit. Now let's see what happens if I'm still seeing there are uncommitted transactions. And that's where the problem is lying. Let's try, instead of commit, well, how about commit transaction? Still seeing that there are uncommitted transactions. Show uncommitted transactions. How can I find out? There are uncommitted. Okay, this is what I want to see. I turned auto commit off by turning on implicit transactions. That's what I did. I ran
Try
my
maybe saying,
go ahead.
Try putting commit transaction instead of just commit.
I did. I changed that to commit commit tran is the same thing as transaction. Commit transaction. I don't think that'll change anything. I'm getting a commit as successful, but when I close that, that's interesting. I didn't get that same. Well, now that, okay. I'm going to say yes to save it. Commit transaction. Let's try that. I don't get that. Okay. What? No. This. Oh, I see what you were saying. Yeah. Okay. Okay. This one is. Yeah, I see what you were saying there. This one is still saying that. So we have a begin transaction. Maybe I've done more begins than I have ends. Still uncommitted transaction. Okay, so this is the one I want to see. I ran the update, then manually ran commit tranny. Yet when I exit, I get this. Why does it ask me even after I did that? It may be it still has some pending transactions. Yes. Please mark this answer helpful. It's not very helpful. It happens every time we open a session and try to close it. Default behavior is the default behavior when implicit transaction is turned on. Now I do have implicit transaction. So I have implicit transactions on, meaning I have auto commit turned off. Maybe I didn't turn it off here. I'm going to say yes. I'm going to say yes to that. File open. Okay. So here I'm going to execute, but I got to the commit there. So I've executed that commit. Now I'm going this one. I'm going to do exactly the same thing. I'm going to execute all of it, and it executed all the way through. Okay, so both of them went from begin to commit. Now I'm going to go back to this one, and I'm going to begin the transaction, and I'm only going to go halfway through. Execute. Now I have an uncommitted transaction, so I would expect if I click that, I would see uncommitted transaction. This one, if I begin, I'm going to expect to see this one hang, and it didn't. Well, what I'm trying to do is I'm trying to begin the transaction, and then I select row one, execute, but I have not committed. Okay, now I go to this other one, and I'm selecting row one again over here, and I'm expecting that to hang. When I expect it to hang, it doesn't, and when I don't expect it to hang, it does. Change it to 2. Hit this one. No problem. Yeah.
Loading over there. If you load it, I think is when the next time that it's gonna say no, I'm sorry, I have the record.
Huh?
Remember, you got something else in the another that is said upload or upload.
UPD lock. UPD lock.
That, I suppose is the moment that it's gonna tell you no, I'm sorry, I cannot give you the record.
Okay, UPD lock is an exclusive lock. That is an update lock. If I just say select, so I've got a repeatable read, and so that should take a lock on that. If I say with an update lock from test batch, so let's put that, with update UPD. Okay. Now that says the update lock. So now what happens when I begin my transaction and I say, okay, no problem. I mean, I'm expecting to, yes, I'm going to do that in a minute. I'm expecting to see it block. What I want to see happen, I want to see it collide and block. And then when I commit one of them, the other one finishes, is what I want to see happen. And that's what I'm expecting, and that's not what I'm seeing happen. But that's what I'm going to make happen. Okay, so this one, if I execute this one, I agree. Well, it doesn't make sense that a minute ago it was blocking and now it isn't. Okay, there we're blocking. Okay, so if I add that UPD lock to both of them, they can't both be taking an update lock. So now what I'm wanting to see happen is when I commit here, execute. So I've committed, and that was the one that was colliding. Now I want to see this other one finish, but it's still blocked. Okay, so anyway, I will work on that. And we can try to that's our task to try to solve our conundrum for the day. Okay, you.
Are you giving us the
Yes,
file? Okay, perfect.
I'll give you the files. I'll give you the web pages that I used. Google is your friend. This isn't real good in our textbook. It doesn't tell us much about it. I'll try to find some better documentation on locking and updating and stuff like that. What I want to do is put a lock at the beginning of one of our procedures. So if we take a lock at when we are beginning to when we're inserting the user, for example, insert player, we really should be locking that so that no other, since we have multiple users running here at the same time, we should be locking. The other thing that I'm thinking that I might try doing is I might try having two different users that have rights to insert into that table. So I'm going to try that and see how that works.
Would you please explain to us where we can create a table to create the user and create the level of the user?
I'm sorry, create the.
For example, when you are going to create a system or a database, you are going to have a quantity of people that are going to be able to use that database.
Right.
And they are going to have different level of access.
Uh-huh.
So in which level I create that access?
Okay. Question is, where do you create your users? Your users would be created in this case by the system administrator. You can create a user that can create other users. So you give that user the right to create other users. It's just one of the roles that you grant them. But I usually just use the system administrator. Now, the thing of it is, I create a user called public user. Public user is just public. So public user has a password. And all of the web pages log in as public user. Public user has no particular rights to anything except what I grant to public. And then public user has the right to do that. So public user, I generally have a web page. When web page comes in, I don't connect to the database with a different username each time. Does anyone else have any other experience with that? My understanding is that you typically have a user that is the web page. The person who comes in is authenticating to the web page. So I might put a password in there with the user. So the RPS player might have a password. And so the web page would check his password before letting him play the game. The idea being that I'm not risking much if someone played the game and didn't pay or something like that. I need to go crowdfunding, get some more people, build up some interest in rock, paper, scissors. Huh? Don't laugh. I have written this program where I know we took 10,000 lines of code to write it. We had a rock, paper, scissors server, which is kind of what we've got here. Okay, I'm gonna go ahead and end there for tonight, but I'm going to keep working on this. And as I come, let me open a discussion area and let's see what we can come up with if we all put our heads to it, because that's a lot about what this course is all about, is figuring stuff out. And so we'll all work on it. So that's my objective, and I'll write that up and as an assignment, if you like. It won't be an assignment, but that's what I'm hoping to get out of this, is that problem solved. So I want to set up, I want a transaction that tries to access something, or that locks that just, I've got a simple little table. One transaction locks one row. Another transaction comes along and tries to access that row, but can't. So it's just, it's waiting. Now I go back to the first transaction, commit, and I want to see the second transaction proceed.
Finish or do something.
Well, he won't finish. He'll select he'll get access to that, and then he or she commits. Okay, so that's where I'm at. Okay. Questions, guys? Online people? Observations? Chris, you're awful quiet tonight.
I am. I'm trying to get different results, but I'm not getting any. I'm getting the same thing as you.
What's that?
Oh, I'm trying to lock it up, and I've got it to, but I can't get it to free now using the activity monitor to kind of take a look.
Let's see. Activity monitor, meaning the task manager?
No, if you right-click on the server and you go to activity monitor, you can, and you go.
Let me try that.
Okay. It's just a different way to have visibility to the locking.
Yeah.
If you go to actually just right click on, right there. There's two ways to do it. There's a report that you can do, or just that monitor in general. Then go to processes.
Processes as well.
Yep. And that will show if
I don't see any processes, resource waits, nothing waiting.
Yeah, you got to do some things and then it'll start populating.
Let's do some things here. Okay, well, he's still blocked. This one is blocked, so I should be seeing him somewhere.
It's paused for some reason at the top. I don't know why.
Yeah, well, he's executing.
No, I meant your activity monitor. It said paused at the top. I don't know why.
Okay.
It's not running.
It says paused.
Yeah, I don't know what that means. Never seen it do that.
Where?
If you scroll up to the top, it said something about paused at the top.
Paused.
Yeah, is there a way you can pause it? That's weird.
I don't know what that means.
Well, anyway, there's another way you could do it. If you go back to the your server and you right click, there's right click reports, which is kind of at the bottom, and then standard reports, and then there's the blocking report that you can refresh.
Okay.
It's under activity and then blocking transactions. Kind of about 1, 2, 3, 4, 5, 6, like 8 down. There you go.
Unable to retrieve data.
No.
View server state.
Oh, permission was denied. Maybe you don't have enough rights in your current user to see the.
Yeah, I'm just logged in as a regular user.
Oh.
Yes.
Anyway, I was using those to watch the activity, and I could see locks, I could see blocks. I don't know how to clear them though. I don't know why it's not clearing them up by doing the commit or rollback. It just keeps the.
Yeah, that's what's bugging me is I may have connected as public user, but I don't think so. I don't have the password in there.
So anyway, that's what I'm just trying to figure out is I can see all that stuff now, but I don't know why the commits and the rollbacks aren't.
Yeah. I'm used to doing it that way, and that's kind of my first exercise when I'm playing around with trying to get transaction locking and to understand it on a particular server. I tried to set up something simple like that and set up a block, one block, two transactions, one of them hits the other one and blocks, and then I commit one and the other one can go. And that's okay. Well, I'm going to switch to lab, and then we'll work on this stuff. I'm going to pausing the recording.